Today I'm going to give it my all for this video. But for real this time, because we're going to show you how a blood test is done. But it's not just about drawing blood. We're going to clear up a question that a lot of people have. Where do those little tubes go after we leave the lab? How do they manage to measure all those numbers, figure out if we're sick, and everything else? Hold on. Where are you taking my blood? To the NTO. What's that? That's where they analyze your blood. But don't they do it right here? No, you have no idea. You have no idea. This is Manual do Mundo. Let's check it out. What we're about to see now is simply the largest high-tech testing facility in Latin America. It's the Technical Operations Center of Hermes Pardini Laboratories, which receives samples by air, by land, by water, from labs all over Brazil. It's here, at the Sample Distribution Center, that the journey of the tubes begins. The samples arrive in a styrofoam box, and they check to see if they're at the ideal temperature. Tubes are taken out of the bags, and here they separate what needs special treatment. But most of them go onto a conveyor belt. From this point on, the automation here is impressive. In the past, all this sample distribution was done by hand. Pardini modernized this process, organized the facility in such a way that people practically don't need to touch anything anymore. All the transportation is done by conveyor belts, which together are over 330 meters long. The first stop is this machine that identifies each little tube, LD. It reads the barcode, then places the tube in a cart, which has RFID identification. It's a wireless communication system, similar to the tag you put on your car at the toll booth. So, from now on, the system knows where each little tube is going. Check out this cool fork in the path. Here is a little RFID antenna, so it identifies whether the sample needs to go through the centrifuge or not. If it does, the sample will already take a different path. With the barcode, they can tell which tests the doctor ordered for that sample. And that's what determines the path each little tube will take inside here. Before the actual analysis, some samples need to go through a preparation process. Here, for example, this machine does a visual inspection. It's a smart camera that will check that nothing is wrong with it. Some samples need to go through a centrifuge. For those tests that don't use whole blood, but only the plasma, the centrifuge can separate these components by difference in density, and the decapper is the last step before the samples go into the equipment. It's in these machines, the analytical modules, where the actual test takes place. Each one of them performs a specific test or a set of tests. There are more than 100 connected along the lines. What happens in here in a very general way? The machine will take a very small sample of the blood that's in the tube, mix it with some substance, and carry out a chemical reaction. It's the result of this chemical reaction that will be analyzed, checking, for example, how much light can pass through it. This will be converted into a number, and then we have the result. One of the most common blood tests is the complete blood count, which will be done on this machine. It will count the red blood cells, the white blood cells, the platelets. To do this, the cells will pass through a microscopic tube where the computer will count how many cells are passing, analyze their shape, and everything else. And based on that, we can find out if the person has anemia, leukemia, infections, and even allergies. If the computer identifies any result that is out of the ordinary, that sample will be sent to a machine that takes a microscopic photo. Then a person will do a manual analysis to ensure the quality of the tests. Every 12 hours, they put a standard sample in the machines. It's a sample for which we already know the expected result, and they check if the machine is working properly. There's a team here just for that. With a small tube, you can run several tests. So after the sample comes out of the machine, it can be automatically sent for another test on the other side of the facility. Since the facility has 2 lines, a sample might enter through one line, but then it also needs to be analyzed in the other one. For that, they built a viaduct, a bridge, so the samples can pass over us.
Here, 15 million tests are performed every month. We serve 2,300 cities in Brazil. What I'm saying is that from the far north of the country to the last city, which is on the border of Rio Grande do Sul, people have access to high-tech tests because we go there every day. 25% of the Brazilian population came through here last year. This is democratizing technology in healthcare.
There are some tests that are done outside the automatic line. Some urine tests, for example. The liquid needs to be placed on a Petri dish to see if microorganisms will multiply there. This process is called inoculation. As you can see here, it's done automatically by a robot. It's a laborious and time-consuming task because, from time to time, someone needs to check to see if anything is growing on the plate. I got some plates here where the bacteria have proliferated. Take a look. The plates go into these incubators that simulate the temperature of the human body. And every 16 hours, someone has to take a look to see if the bacteria are growing. The bacteria's food and the culture medium, some enzymes are added. So when they form colonies, you can tell by the color what type of bacteria is there. If I were watching the video right now, the like button would be pulling my finger like a magnet. This laboratory is one of the places where the most PCR tests are done in Brazil. When you hear about it, we always think of COVID, but you can detect several other diseases because it's a test that can find genetic material.
PCR detects specific sequences of the COVID virus RNA, so it's a more specific test because it targets regions of the RNA that we know belong to the virus. And it's also a more sensitive test because of the PCR technique. So it has a lower chance of giving a false negative result and a lower chance of giving a false positive result as well.
This is much more reliable.
Much more reliable than the rapid test.
Now, the test I've always wanted to know about, the karyotype test, which is the analysis of chromosomes. They are tangled structures formed by our DNA. Each one contains a part of the genetic information of our body. Their number and shape can indicate several things, like Down syndrome, for example. These little red arrows here show a sample where leukemia was found. Laboratory is so big that they even have a control room. Here they monitor and control all the processes, not just from here, but from all the Pardini Group's facilities. Standard Laboratory in Goiânia, Paulo Azevedo in Para, Centro de Medicina in Rio, IACS in Santos, and Solução in Santa Catarina. It operates 24 hours a day, 7 days a week. And here, they have direct communication with the people working on the line to ensure that no supplies are missing or that any equipment failure is fixed as quickly as possible. And now, the big question. Where do the blood tubes go after the tests are done? First, they are sealed with aluminum foil, like a yogurt lid, and then they go to these giant storage units called biorepositories, kind of like a library of samples. No one goes in here. Everything is controlled by robots. There are 4 biorepositories, and the total capacity is over 1.3 million samples. The amount of time they'll stay in here varies depending on the test. It's important to store them for a certain period, because then you can repeat the test. Or the doctor might request another test based on the same sample, so the person doesn't even need to have their blood drawn again. When the storage period ends, the tubes will be automatically discarded and sent for incineration. I bet you didn't imagine there was so much technology involved in your blood test after it leaves the lab, and we can expect much more, because Pardini Group is a pioneer in laboratory test automation, and all this investment is definitely worth it, because besides reducing the cost per test, they also shortened the delivery time, with more than 82% of the results delivered in less than 6 hours. The result is online on the website and app. I think my result is already out. Is it?
Saiu.
All good.